Hello dear viewers, welcome to TV Math. For those that are new to this channel, TV is my name and here is my contact, and you can also reach me through this email. At TV Math, we support you with full video lessons in mathematics, one-to-one online tutoring for learners who need personal support. We provide exam focused revision series. We provide clear step-by-step solutions in very many mathematics topics. We provide you with practice questions with guided marking approaches. So today, I want us to begin a topic that is about trigonometry from the scratch. And we shall be focusing on key trig ideas, clear working methods, and exam style understanding. If you are new to this channel, please make sure you subscribe to TV Math. This channel is built to help you improve your grades through consistent learning. We already have ongoing series. On one, a standard paper revision. I've already uploaded up to 3 revision items for A level following the assessment guidelines. So in case you are still not sure of how you will attempt your final exams for mathematics, please, I've already discussed about the guidelines. I've already discussed about some of the examples and how the questions or the items are set for A level and new curriculum. So in case you haven't watched this video, please, I will attach the link in the description such that you watch and understand what you are supposed to do in your mathematics paper, that is paper 1 and paper 2. I have an ongoing series about vectors. I've also uploaded about 2 vectors, that is up to lines. So now we shall be having more uploads on lines and planes. Vectors, that is vectors in 3 dimensions, that one is done. And you should also check for those videos. Make sure you simply subscribe to TV Math. It is completely free of charge, but you will always get notified whenever a new video is uploaded. So I only require you to be consistent and follow the full series, because each lesson connects to the next. So make sure you watch all of our videos. So let us look at trigonometry. Before we look at trigonometry, I believe this is not new to us. You have already talked about trigonometry in O level. So I believe at the moment you know what sine of an angle is. You know what cos of an angle is. You know what tan of an angle is. If you recall very well, you talked about something to do with SOHCAHTOA. So you did something to do with SOHCAHTOA in your ordinary level. So I believe at the moment you have the basic knowledge about trigonometry. However, we shall be able to include some more concepts when it comes to A level. So at the moment, let us talk about what is elementary trigonometry. So elementary trigonometry deals with the fact that in any set of right angled triangles, the ratios of the corresponding pairs, of sides remain constant. So trigonometry basically deals with the relationship between sides and angles. And when we consider, for example, right angle triangle, this is the triangle that we were considering. So having an angle here, which is angle theta. Then we have got this right here to the theta is called the adjacent. We have got the side which is opposite to the angle, and that is the opposite side. We have got this long line here is what we call the hypotenuse. So in the right angle triangle ABC with the right angle at B, this is where we have our 90 degrees. We are saying the angle at A is what we are calling theta. The opposite side is the Y, that is the opposite side, and the adjacent side to theta is the X, this one here, and the hypotenuse is this R here. This line here is what we call the hypotenuse. But of course, if this angle theta also changes and you are having your theta here, then it means the opposite side will become this. This becomes the adjacent side, this becomes the opposite side, and this one here remains what we call the hypotenuse. Now, having looked at this, I want us to look at what is a sine of the angle theta. So I'm referring to this angle, I'm referring to that angle. So if I refer to this angle, what will be sine of theta? Sine of theta, as you all know, is defined by opposite over hypotenuse. So what is the opposite? The opposite here is y. The hypotenuse here is r, meaning that sine of theta is y divided by r. When we talk about cos of theta is the adjacent. You need to recall from SOHCAHTOA. You need to recall from this that the cos of an angle is adjacent over hypotenuse. But what is the adjacent? This is x. What is the hypotenuse? That is r. So what is tan of theta? Tan of theta is opposite over adjacent. Opposite over adjacent. But with respect to this theta, what is the opposite? Is y. The adjacent is r. That is what we have. But when we come to A level, we shall be introducing more trig identities. So we know that when we are in O level, we talked about sine of theta, we talked about cos of theta, we talked about tan of theta. These are the three trig ratios that we were talking about. But when it comes to A level, we shall look at other three trig ratios, and those are the reciprocals. We shall now talk about the reciprocals of these trig ratios. So we shall talk about what is the reciprocal of sine. That is 1 over sine of theta. So when we are talking about 1 over sine theta, we shall be talking about what we call cosec of theta. So we shall introduce in another term, that is cosec, and cosec means 1 divided by sine. So for us, we had sine, but if you were looking at the reciprocal of sine, then you call that one cosec. When you are looking at the reciprocal of cos, you are looking at 1 divided by cos. Then this one, we shall be calling it sec of theta. When you are looking at the reciprocal of tan, so that is tan of 1 divided by tan of theta, we shall be saying this is cot of theta. So these are the three more trig ratios that we shall be talking about. So what is cosec? Cosec of theta is 1 over sine of theta. What is sec? Sec of theta is 1 over cos theta. What is cot? Cot of theta is 1 divided by tan of theta. Now, it means if I have, for example, sine of theta as 1 over 2, what will be? What will be cosec of theta? Cosec of theta is simply 1 divided by a half. In other words, the reciprocal of this. What is the reciprocal of that? That is 2. So that will be cosec of theta. So cosec is 1 divided by sine of theta. So if you have sine of theta, you can get cosec of theta. And we shall always be defining these reciprocals in terms of their corresponding trig ratios. So you must know that we shall have now these three other terms. What is most important thing here I need you to know is we have seen that cot of theta is the same as 1 over tan of theta. But I also want to know what is tan of theta in terms of sine and cos. If you have seen clearly what we have done here, we said that tan of theta is y over r. But can you realize that if you say tan of theta is, okay, what was tan of theta? Oh, tan of theta is opposite of adjacent, the adjacent is x not r. So if you say that tan of theta is y over x, can you realize that this is same as y over r divided by x over r, which is same as y over r times r over x, and this cancels. You get this as y divided by x. You realize that. So you have y divided by x. But this one here is coming from y over r divided by this. In other words, this is still same as y divided by r is what we saw as sine of theta. So we are dividing this by x over r, which we have seen is cos of theta. So the moment you are talking about tan of theta, we shall always be saying that tan of theta in terms of sine and cos is sine theta divided by cos of theta. Now it means if we talk about cot of theta as 1 divided by tan of theta, then we are saying it is 1 divided by tan, which is sine theta over cos of theta. So this is same as 1 divided by sine theta over cos theta. And this is same as 1 times cos theta over sine theta. So what does this imply? This implies that cot of theta is the reciprocal of tan of theta. And if tan of theta is sine over cos, then cot is the cos over sine. So those are some of the trig ratios that we shall be talking about. So we have already seen the reciprocal of sine, the reciprocal of cos, and the reciprocal of tan. So the reciprocal of sine is cosec. Sometimes we write it like this, but whenever you are writing, you can simply say that is cosec of theta. And cosec of theta is 1 divided by sine of theta. But by computer, you write cosec as CSC. So this is the computer language now. But whenever we are writing, if you meet this one in this work here, it means cosec. So you shouldn't get confused. But we shall always be writing it using this one here for a better understanding. So we have seen cosec is 1 over sine. We have seen sec is 1 over cos. We have seen that cot is 1 over tan. But that is still same as cos of theta divided by sine of theta. So having looked at that, so I believe at the moment you know what is the reciprocal of sine, what is the reciprocal for cos, and what is the reciprocal for tan. So now before we continue, can you put for me in the comment section what the reciprocal of cot is? So put for me what is the reciprocal of cot? 1 over cot of theta. What is the reciprocal of cot? What is 1 over cot of theta? So put it for me in the comment section. If I'm talking about 1 over cot of theta, so what will it be equal to? So 1 over cot of theta is equal to what? I want the answer in terms of tan. I want the answer in terms of sine and cos. In terms of sine and cos. So put it for me in the comment section. What is 1 over cot of theta? If cot of theta is equal to this, then what is 1 over cot of theta? Okay, so that will bring us to what we call the types of angles. So let us talk about types of angles. So we shall be saying that an angle is formed between two rays with a common initial point. And we have got these types of angles. One, we have got what we call the acute angle. We have got what we call the acute angle. And what is that angle? That is an angle whose measure is greater than 0, but less than 90 degrees. But less than 90 degrees. So whenever you are talking about acute angles, then you are looking at the angles which are from 0 to 90 degrees. Please, you need to master some of these things here, because we are going to be referring to such angles here. So whenever we say what is an acute angle, you should be able to recall that such an angle is an angle that is between 0 degrees and 90 degrees. So you should always recall that, because we shall always be referring to this angle here. So what is the right angle? So I believe you know that that is an angle whose measure is exactly 90 degrees. Then we have got another one which is called obtuse angle. So an obtuse angle is an angle whose measure is greater than 90 degrees, but that angle is less than 180 degrees. Then lastly, we have what we call the reflex angle. What is the reflex angle? That is an angle whose measure is greater than 180 degrees, but less than 360 degrees. So those are the different types of angles we shall always be talking about. Then we have got something to do with special angles. So dear students, we have what we call the special angles, and these angles are 30 degrees, 45 degrees, 60 degrees. So when we talk about special angles, it is always important to know what is the sine of 30 degrees, what is sine of 60 degrees, what is cos of 45, because these are special angles, so they have got special expressions. So we shall always be referring to these angles, especially when we are talking about special angles. And whenever we talk about special angles, you should now be able to look at what is the cos, what is the sine, what is the tan, and all those. How do we get those angles? How do we get the sine of 30 degrees? How do we get the sine of 45 degrees? So we shall begin with 30 degrees and 60 degrees by considering this quadrilateral, this equilateral triangle. So we want to consider the equilateral triangle. So having the sides equal, all these sides are equal. So, and we are using 2 units to represent that length. So if this is 2 units, it means this part and this one gives us 1. So if this is a equilateral triangle, it means the angles are equal, and it means they are equal to 60 degrees, such that they add up to 180 degrees. So the whole of this is 60, meaning this is 30, this is also 30 degrees. Now from there, our interest is to get sine of 30, cos of 30, and tan of 30. So we need to know the respective trig ratios for these angles. As I said, we shall always be referring to some of these angles here. Let us see how best can we prove or get the corresponding expressions for these angles. So we are saying that this one here is root of 3 simply because we are picking one right angle triangle. This is at 90 degrees, so this is 2, this is 1, so this is like 30 degrees, this is like 60 degrees when you pick one of these right angle triangles. So if this is like h, then using Pythagoras theorem, h squared plus 1 squared is 2 squared. So h squared is 2 squared minus 1, so that will be 2 squared minus 1 squared. So h squared will be equal to that is 3. So h is the square root of 3. So you will have your h as the square root of 3. So that's why we have the square root of 3 here. Now I want us to get what will be sine of 30 degrees. Sine of 30 degrees. If this is 30 degrees, sine is opposite. What is the opposite? Is 1 divided by hypotenuse. What is the hypotenuse? For example, consider this. If you consider this right angle triangle, so my triangle seems not to be a right angled one. Okay, this is okay. So if I'm considering 30 degrees, what is sine of 30? Opposite over hypotenuse. So sine of 30 is 1 over 2. What is cos of 30? Cos of 30 degrees? Adjacent, which is root 3 over hypotenuse. That is root 3 over 2. What is tan of 30 degrees? Tan of 30 degrees, tan opposite over adjacent, 1 over root 3. Or which you can write as root 3 over 3 when you rationalize. So there we shall be able to get sine of 30 degrees. Then we talk about cos of 60 degrees. Consider 60 here. What is cos? The adjacent is 1. Hypotenuse is 2. What is a sine of 60 degrees? Sine of 60 degrees. Sine is opposite root. That is opposite. That is root 3. Root 3 are divided by hypotenuse, which is 2. What is tan of 30 degrees? Tan of 30 tan of 60 degrees. Tan of 60 degrees is tan is opposite over adjacent. So that is root 3 over 1, which will be root 3. So this is the cos, sine, and tan of 30 degrees and 60 degrees. So you should always know these expressions here because they are important. At some point we shall always refer to them again. So we shall be able to get these expressions corresponding to sine of 30 and corresponding to angle 30 degrees and angle 60 degrees. So those are the expressions that we have talked about. Now next I want us to look at another angle. Another special angle is 45 degrees. So to look at that, we shall consider an isosceles right triangle, a PQR, that has got these sides equal. And of course, if this is equal to this, then we can get this using the Pythagoras. So if this is the hypotenuse, which is h, then we can easily get this h by getting 1 squared plus 1 squared is equal to h squared. So 2 is equal to h squared, giving us h as square root of 2. So what will be sine of 45 degrees? This angle here is 45, and this angle here is also 45 degrees. So that is sine of 45. I can choose this one here. So the opposite is 1. The hypotenuse is root 2. When you look at cos of 45 degrees, and in most cases we can also write this as root 2 over 2 when we rationalize. Also cos of 45, this is 1 and divided by, so that is 1 divided by root 2. Remember, cos is adjacent over hypotenuse, so that's why I'm writing 1 over root 2. So you can also have this as a root 2 over 2. What will be tan of theta? Tan of theta is opposite. Opposite is this. I'm considering this angle here. Opposite is that. This is the adjacent. So that is 1 over 1, which is 1. So those are our special angles. But as I said, you need to always recall these ones here, such that when they say what is 60 degrees, then you know it is root 3 over 2. What is cos 60 degrees is that. So how do we easily recall that? I have the way how we can always recall that, and that one there I will take you through that. So when you want to recall some of these expressions easily, so here we have, for example, sine of the angle, here we have the angle, here we have sine, here we have cos, and here we have tan, and here we have tan. So if we want to recall that, let us look at special angles. We have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So you want to recall some of those expressions that we have seen, other than getting them or deriving them afresh from the equilateral triangle and the isosceles triangle. Other than doing that, how do we easily get that? So what you do, simply have this one start with 0, 1, 2, 3, and 4. Start with that. When you put that one there, so the next thing, take the square root on both sides. Square root of each of the terms. Square root of that, square root of that, square root of that, square root of that, square root of that. So next, half each of them. Next, half each of them. So this one here, divide it by 2. Divide this by 2. Divide this by 2. Divide this by 2. Divide this by 2. So what shall we have? Looking at that, you should be able to see square root of 0 divided by 2 is 0. Square root of 1 divided by that is a half. Square root of 2 divided by 2 is it remains square root of 2 divided by 2. Square root of that of root 3 divided by 2, it remains. Then this is square root of 4, which is 2 divided by 2, which is 1. So this becomes 1. So you can easily see that you have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So what are you getting? You are getting the first one for sine. You are getting 1, 0. 0, a half, root 2 over 2. You are getting root 3 over 2. You are getting 1. So when you look at what we obtained, here, so what was a sine of 30? Sine of 30 was a half. Do we have a half here? Yes, it is a half. This was root 3 over 2. Sine of 60, root 3 over 2 is there. Then 90 degrees, sine of 90 is 1. So you can get the answer there very easily. So you can see how we can easily obtain the values. That is for sine. So let us talk about for cos. So when we are to talk about the one for cos, we shall follow the similar procedure. Here we started with 0 for sine. Now here you will start with 4 instead. So you start with 4 here. Then this one becomes, so this is 4, this is 3, this is 2, then this is 1, and this is 0. So reverse. So here we started with 0. Now this side start with a 4 for the cos. Then the next thing is to take the square root for each of these. So take square root for each of them. Take square root for each of them. I will do that. So the square root of this will give us 2. The square root of this will be root 3. Square root of this will be root 2. Square root of 1 remains 1. Square root of 0 remains 0. So the next thing, divide by 2. So divide this by 2, you will get 1. Divide by this by 2, it remains. Divide this by 2, it remains. Divide this by 2, then divide by 2, it remains 0. So you will have 1, you will have root 3 over 2, you will have root 2 over 2, that is 1 over 2, and 0. And you will be able to get that. So that will be how you can easily recall a sum of these things. So for tan, we know tan is same as sine over cos. Tan is sine over cos. So if tan is sine over cos, what is 0 divided by 1? That is 0. What is a half divided? So that is a half. So we are getting this divided by this. A half divided by root 3 over 2. So that is a half times 2 over root 3. So that will give us 1 over root 3. Let us look at this. This divided by this. This is root 2 over 2 divided by root 2 over 2, which is 1. You are having root 3 over 2 divided by that. That is multiplying by reciprocal. That is root of 3. So we shall have root 3. Then next we shall have this divided by this. So when you have a number 1 divided by that, that will be undefined. So tan of. So next we would like to come to the measurement of angles. So how do we measure angles? So angles can be greater than 360 degrees. Angles can be positive. This should be. Angles can be positive or negative. Angles can be positive or negative. So then, how do we measure such angles? We measure angles from the positive x-axis. Whether positive or negative, we measure them from the positive x-axis. So let us see. For positive angles, we shall be saying that all positive angles are measured. All positive angles are measured anti-clockwise. From the positive x-axis. So how do we do that, or how do we represent that? So if you are measuring an angle, for example, in this quadrant, we are going to talk about the quadrants. So we have got the first quadrant, the second quadrant, the third, and the fourth quadrant. So we have this as the positive x-axis. Then we have to take the angles following the clockwise or anti-clockwise direction. The anti-clockwise direction is this. So if you move like this, you are measuring a positive angle. So if this is, for example, angle 45 degrees, then here this is positive 45 degrees. So the angle that is measured take following this direction. If you are following this direction, you are measuring a positive angle. So this is a positive angle. So whichever angle is obtained by taking this direction, you represent it with a positive value. Then we measure negative angles following the clockwise direction. So the clockwise direction is this. So if I take this direction, that one becomes a negative angle. Which means if this is 45, then this angle will be, remember, if I complete this circle here, then it becomes 360 degrees. So it is same as getting 360 minus 45, and this is 315 degrees. But that 315 degrees is a negative angle, so it is negative 315 degrees. So when you take like this, it becomes positive. You take like this, it becomes the negative angle. If, for example, I look at this, if I have this, and I'm taking this angle from here up to this given point, this angle here is 270 degrees, because this is 91, 80 to 70. But what is the corresponding negative angle? When I measure from here to here, then this angle becomes negative 90 degrees. But all of them must be measured from this axis, which is the positive x. Whenever you are taking an angle, you take an angle starting from here, either going anti-clockwise or going a clockwise direction. So that is how we measure angles. So we follow anti-clockwise and clockwise. If it is anti-clockwise, then that means the angle will be positive. Clockwise, the angle will be negative. So we want to talk about the quadrants. So whenever you have a circle, if you have a circle drawn with the center at the origin, with the center at origin, or dividing a circle drawn with the center at origin, or divides the coordinate. That circle will divide the coordinate axis into 4 quadrants, into 4 equal parts, and these parts here are called quadrants. So if you have a circle, so this is our coordinate axis, but if you draw a circle, with the center at this origin O, then this circle will divide this coordinate axis into 4 parts. So that is the first part, and they are named following the anti-clockwise direction. Second part, this is the third part, and this is the fourth part. And we call this the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now, before I talk more about that, I wanted us to give a general conclusion here, especially on measurement of angles. This is very important to know how to measure angles. So I need to again emphasize something here before I go into details with the quadrants. So it should be clear. That from what we have seen, from that illustration we have put there, that Actually, there are two of them. So this one and this. So I want us to give some conclusion that is clear from the illustrations that if the angle is positive 45, for example, if the angle is positive 45 degrees, this angle is equivalent to, this angle is equivalent, if this is 45, then this angle, which is a positive angle, is equivalent to the negative angle, this negative angle, which is negative 315 degrees, is equivalent to negative 315 degrees. What does that one imply? It means if you are taking sine 45, it is same as having sine of negative 315. The two are equivalent. They are not equal, but they are equivalent. If you take tan of 45 degrees, it will be the same answer as tan of negative 315 degrees. You will get the same answer. So these are equivalent. If I say positive 270 degrees, then the equivalent negative angle is this, the negative 90 degrees. When I say positive 270 degrees, its equivalent negative angle is negative 90 degrees. So having negative 90 degrees is same as having 270 degrees. The two are equivalent angles. Likewise, if, for example, you talk about this, maybe your angle is in this quadrant. This is 60 degrees. This angle from here to here is, from here to here, this is 0 degrees. This is 180 degrees. This one here is 90 degrees. This one here is 270 degrees. And coming back here, it becomes 360. So taking this angle here, this is 180 minus 60, which will be same as 120 degrees. But this angle is same as its equivalent angle taken in the negative direction. So what is that angle? So that is same as getting 180 plus that, or 360 minus this itself. So 360 minus 120, you get 240 degrees. So it means if I have 120 degrees, it means if I'm looking at positive 120 degrees, this is equivalent to having a negative of 240 degrees. So cos of this one is same as this, cos of this, tan of this is same as this, tan of that. So that is what we can say. So in general, what can we say in general? In general, we can say that if you have positive angle theta, this is equivalent to negative of 360 degrees minus theta. Whenever you look at this, if the angle is 45, this angle is same as negative of 360 minus 45, which is 315. If this is 270, the corresponding angle, this angle here, is same as 360 minus 270 degrees, negative of course. This is same as 360 minus 45 degrees, negative. This angle here is same as having 360 degrees minus 120 minus 120 degrees. But of course, this is also in the negative direction. So clearly, in general, you can say this, or else you can say whenever you have a negative angle, that angle is equivalent to 360 minus theta. 360 minus of theta. So that is what it is equivalent to. Meaning if you have negative 45 degrees, it is same as having 360 minus 45 degrees. So that is the corresponding positive angle. So that is how we obtain angle. So as you can see, whenever you have a positive angle, you can easily get the corresponding equivalent negative angle. So let us go on and look at our quadrants. As we have seen that if a circle is drawn with the center at the origin, then it divides the coordinate axis into 4 quadrants. And those quadrants are named following the anti-clockwise direction. So that is the first, the second, the third, and the fourth quadrant. So looking at that, that is basically what we are talking about. So these are the different quadrants. And from these, we have got these standard angles. 0 degrees is here, and 360 degrees is here. So this angle, the whole of this angle gives you 90 degrees. So we have 90 degrees here, we have 180 degrees here, then we have 270 degrees here. And of course, as you know, if I take this angle from here to here, I get 180. But this 180 is also equivalent to this angle, as we have seen, which is in the negative direction, meaning 180 degrees is equivalent to the negative 180 degrees. So this is the positive angle, and when I take this direction, I am measuring the negative angle. So these are the angles that we have already fixed on our quadrants. So these are special angles that we have there. So 0 is here, 360 is here, 90 is here, 180 is here, 270 is here. And we shall always use some of these angles here. So any other angles are within this quadrant, this part here. So any of other angles are within this part here. So if you have any angle between 0 and 90, then it will be within this part. The angle between 90 to 80 will be in this part. The angle between 180 and 270 will be like in this part. So that is where we can have our different angles. So we have seen that the plane is divided into 4 quadrants. The first quadrant is from here, from 0 to 90 degrees. The second from 90 to 180. The third is from 180 to 270. The fourth is from 270 to 360 degrees. So those are the various quadrants. Now within these quadrants here, we can obtain the nature for sine, cos, and tan by looking at this. So what will be the nature for cos? What will be the nature for sine in those different quadrants? So I want us to consider these quadrants here. We consider, for example, this angle theta. If we consider angle theta, then I can easily form a right angle triangle here. So I want to consider this as r, this as y, and this is x. So I want us to first look at the first quadrant. So in the first quadrant, what will be sine of theta? Sine of theta is opposite, that is y over x. And y here is positive because this is in the positive direction. X is in this direction, which is positive. So here it is positive. What is cos of theta? Cos theta is x over, okay. This is y over r, not y over x. Because this is y over this. So this is x over r. So this is positive. This one is positive. The reason why we are saying that is that y is positive, is in the positive y-axis. X is in the positive x-axis. What about tan of theta? Tan of theta is opposite over adjacent, which is also positive. We need to look at the nature of trig functions in this quadrant, this quadrant, this quadrant, and this quadrant. So you realize in this quadrant here, all trig ratios are positive. All trig ratios are positive, which means if all trig ratios are positive, then their reciprocals are also positive. That one you should also be aware of it. Because if sine is positive, then it means its reciprocal, which we said is cosec, it will also be positive. Let us talk about the second quadrant. I want to allocate this angle now in the second quadrant. So if I have the angle in this quadrant, this is where I'm having theta. So this r will always be positive because it is obtained by getting this squared plus this squared. But as you can see, the x will be in the negative direction. That is in the negative side. And then from here, the y is in the positive y-axis. The x is in the negative direction because this side we have negatives, this side we have the positives. Because this side we have the positive y, here we have the negative y, here we have negative x, here we have positive x. So what will be sine of theta? Sine of theta in that quadrant, sine is opposite, which is y, over hypotenuse, which is r. So y is positive, this is positive, you get a positive value. What is cos of theta? Cos of theta is adjacent, negative x, over the hypotenuse, which is r. So this r is positive, this is negative, this will give us a minus. Next, what will be tan of theta in that quadrant? Tan is opposite y over adjacent negative x, which is negative y over x. So this will also give us negative. So in this quadrant, what it means is that in this quadrant, only sine is positive. Only sine is positive. Others, cos and tan, are negative. So here, sine is positive, cos is negative, tan is negative. Here, sine is positive, cos is positive, and tan is positive. Okay, we can go on and get the nature of the angle in this quadrant. So let us also allocate the angle in this quadrant. So we shall allocate that in this quadrant. So we shall have that. Still, this is negative x. Y is also in the negative direction. So this is negative y. So here we still have our r there. So why it is sine of theta? Sine of theta is opposite. We are referring to this angle now. That is opposite negative y over r. So which will be a negative value. What is cos? Cos is adjacent over hypotenuse, negative x over r. What will be tan? So this is giving us negative as well. Tan is opposite, negative y over hypotenuse, which is negative x, and this will be positive, so giving us y over x, which is positive. So in this quadrant, it is only tan which is positive. So here you have tan positive, sine is negative, cos is negative. And lastly, we come to this quadrant. So in this quadrant, still I will have this as x. Now y is in the negative direction. This is negative y-axis, so this is negative y. So this is still r. I want to consider this angle theta. So what will be sine of theta? Opposite, negative y. Hypotenuse r, giving us a negative. Cos of theta, adjacent x, hypotenuse is r, giving us positive. Tan of theta. Tan of theta is opposite, negative y, over adjacent x, giving us negative. So whenever you are looking at the fourth quadrant, cos is positive, sine is negative, cos is positive, sine is negative, tan is also negative. So what does that one imply? We come up with one of the mimics that will help us to always represent this one here. So as you can see, this can be easily summarized as the first quadrant. We have all of them positive. This one only sine is positive. This one only tan is positive. This one only cos is positive. So sometimes we normally use some of the words to help us recall some of these things. So we have seen that in the first quadrant all the trig ratios are positive. Second, only sine is positive. Third, only tan is positive. In the last one, only cos is positive. So how do we always, or how can we always remember that? So we can use different expressions. For example, that you can say add a sugar to coffee. Add sugar to coffee. So what does that one mean? Add sugar to coffee. So you can easily recall that. All science teachers K. All science teachers K. So all science teachers K. So whenever we want to recall some of the signs in these quadrants, we can always use some of these words to remember some of those things, some of the nature of the signs in these quadrants. Okay, so you can add as many as possible. All students try coupling. That one is also there. All students try coupling. You can use that one. So all students try coupling. But whenever we are putting them, we put them following that direction there. That is the anti-clockwise direction. So that is how we can remember the nature of signs in those quadrants, and that is what is summarized there. You can also use all students take calculus, all students take chemistry to remember some of those ones there. So we have seen about the nature of signs of different trig ratios in different quadrants. Now we want to look at, if at all you have an angle theta here, how do you get that angle? So that angle is same as either starting from here, this is 0 degrees, you start from here up to here. That is how we measure the angles. So whenever you get an angle, you rotate it with respect to the x-axis. So if you want to put an angle in this quadrant, make sure it is put with respect to this x-axis. In this quadrant, put it with respect to this axis. In this quadrant, to put the angle in that quadrant, you locate it using the reference as the x-axis. So if you want to get this angle here, then you will take the whole of this from here up to here. And what will that one be? Because I know this is 180 degrees, I know this is 270 degrees, I know this is 0, and that is where we complete our revolution, 360 degrees. So if I want to get this angle, it is same as getting 180. I subtract this angle, so I get 180 minus theta. So if I need to get the angle in this quadrant, I must move from here and come up to this quadrant here. And how do we get that? That is 180 degrees plus theta. So it means this is 180 up to here. From here up to here is 180. So I want up to here. So this one here is 180 plus that. If I want the angle in this quadrant, I must move like this. That is moving up to this given point. So how do we get that? It means the complete one would have been 360 degrees. But if this is theta, then the remaining angle, this angle here will be 360 minus theta. So that is what you obtain. So that is how we obtain angles in the different quadrants. But of course, don't forget that whichever angle you get, it has got the negative angle. Now, like this 360 minus theta has this one as the negative angle. This angle, when I move like this up to here, this is also like 180 minus theta, because I need the angle from here up to here. But that 180 minus theta will be in the negative direction, and that will be a negative angle. So if I move like this, I'm measuring negative angles. If I move like this, I'm getting positive angles. So next, I want us to talk about how do we express some ratios as trig ratios of acute angles. How do we express acute angles as how do we express them as acute angles? We have talked about an acute angle. Where basically we said an acute angle is that angle which is in the first quadrant. That is in this quadrant here. Remember, acute angles are from 0 degrees to 90 degrees, meaning they are in the first quadrant. Then if you have obtuse, as we have seen, that is the angle from 90 to 180 degrees. So that is in the second quadrant. This is in the second quadrant. We have talked about reflex, where we said that these are angles from 180 degrees to 360 degrees, and such angles are the angles in the second, that is third, and fourth quadrant. So those are what we call the different angles, and how we can locate them in different quadrants. So our next task is to express general angles, different trig ratios as or in terms of acute angles. So any angle theta has the same trigonometric ratios as its acute angle. So how do we show that sine 150 degrees can be expressed in terms of acute angles? That is in terms of 30 degrees. So can we look at that? So our question is saying we need to express. The question is, you express each of the following. Express each of the following as trig ratio of acute angles. So how do we do that? We begin with sine of 150 degrees. So 1 is sine of 50 degrees. So how do we express this as a trig ratio of an acute angle? So what you do is go to the quadrants. Where is 150 degrees? So if this is 0, this is 180 degrees. So 150 degrees is, remember, this is 90. So it means 150 degrees is between 90 and 180. And that this is a positive angle. So if this is a positive angle, then it means I need to take the anti-clockwise direction like this. Since it is between here, then I can locate it in this quadrant. So this is where we have 150 degrees. So if this is 150 degrees, what is this remaining angle to the x-axis? This remaining angle to the x-axis is same as 180 minus 150. So that will be 30 degrees. So what you will have is, you will say sine 150 degrees is equal to, so you express it in terms of this angle, which is to the x-axis. Now, that is sine of 30 degrees. But as we said that in this quadrant, what is the nature of sine? We still say all students take chemistry. So in this quadrant, sine is positive. So this will be positive. You put the positive sign there. So sine 150 degrees is same as positive sine 30 degrees. So whenever you are in a quadrant, you must look at the nature of the trig ratio in that quadrant. So that is what we get. Part B, we can look at what is cos of 120 degrees. Cos of 120 degrees. Again, draw your quadrant. You know this is 90, this is 0, 180, this is 270, this is 360. So where is 120? 120 is between 90 and 180. So 120 must be in this quadrant. Must be in this quadrant. So how do we locate that? I move like this. That is where you locate 120. So this is where we have 120 degrees. But what is this remaining angle? What is this remaining angle to this axis? To the x-axis. So it's same as 120 minus 180, 180 minus 120, which is 60. So what does that imply? It means cos 120 degrees is the same as, first write this, cos of 60 degrees. Then after writing that, don't stop there. Look at in this quadrant, what is the nature of cos? What is the nature of cos in this quadrant? All students take chemistry. All are positive, only sign is positive, only tan is positive, cos is positive here. So in this quadrant, only sign is positive, others are negative, meaning if any cos inclusive is negative. So place a negative with that. This implies that cos 120 degrees is same as negative cos 60 degrees. So that is how we obtain that. We take the angle to the axis. We take the angle to the axis. So I hope that one is clear. We can look at another example to understand this concept well. So let us look at sine of 240. What is sine of 240 degrees? Sine of 240 degrees, again, put it to your quadrant. Locate 240 on your quadrant. So if this is 0, this is 90, this is 180, this is 270, this is 360. You go on like that. 360 plus 90, 450. 450 plus 90, 540 plus 90, 630 plus 90. You make the second revolution. So this is how we get all the angles there. So you can keep on like that. But my interest is to get 240. What is 240 and where does it lie? 240 lies between 180 and 270. So it must be in this quadrant. So I will locate that using this. So it means this will be my 240 degrees. So if that is 240 degrees, then what is this angle? Remember, we take the angle with respect to the x-axis. So from here to here is 240, but from here to here is 180. So that remaining angle is 240 minus 180. So what is 240 minus 180? This is 60 degrees. So this angle here is 60 degrees. That angle is 60 degrees. So what do? We say sine 240 degrees is equal to sine of 60 degrees. But what is the nature of sine before you say they are equal? What is the nature of sine here? So the nature of sine in this quadrant is the nature of sine in that quadrant should be able to tell it at the moment, or as students take chemistry. So the nature of sine in this quadrant is negative, because on return is positive in this quadrant. So this will be a minus. So that is how we obtain that. So you must get this angle to with respect to this axis here. So we look at part D. So let us talk about, what about if you have a tan of 320 degrees? So locate that angle on your quadrants. So this is 90, this is 0, this is 180, this is 270. So where do we find it? 320. 320 is in which quadrant? 320, this is 90, 180. 320 is above this, so it must be between 360 and 270. So it is within this quadrant. So you move like this until you meet that line there. So this is where we have 320. But if this is 320, what is this remaining angle to the x-axis? The remaining angle to the x-axis is 360 minus 320 from here up to here, giving us 40 degrees. So what will the answer be? Write your tan of 320 degrees equal to, write again here, tan of now this angle, 40 degrees. But what is the nature of tan here? Are you able to tell the nature of tan in this quadrant? The nature of tan in this quadrant is a minus. If it is a positive, put it there. If it is a minus, also put it there. That is our part D. So what is the next one? Part D. Let us look at part E. Let us talk about tan of negative 135 degrees. So this is tan of a minus. So you must know how do we locate a minus on our quadrants. So when we are talking about this is our 0, this is our 90, this is our 180, this is our 270. But the moment you are looking at the negative sides. So it means this is 0, this is negative 90, this is negative 180, this is negative 270, this is negative 360. You are taking this direction now. You are taking the clockwise direction. So where do we have 135? So move from here. When I move like this, I reach here, it is 90. So 135 must be between negative 90 degrees and negative 180 degrees. So it must be in that. So this is negative 135 degrees. That is taken from the clockwise direction, not the anti-clockwise, this one. So this is where I have negative 135. But what is this remaining angle? So if from here to here is 135, and from this given point here, this is 180, this from here to here is 135, so I can simply get 180 minus 135. So that remaining angle here will be, so 180 minus 135. So the remaining angle here is 45. Don't represent this angle with a minus or to put the minus. That angle should always be a positive angle, the one that you put with respect to the x-axis. Now, if I need the corresponding angle there, so I have tan of negative 135 is equal to, now I first write tan, this one, of the angle which is 45. Then I look at the nature of tan in this quadrant. The nature of tan in this quadrant is positive, so which means that tan of negative 135 is the same as tan of 45 degrees. That is what we shall have. So you are placing this in terms of the acute angles. With that, can we look at A, B, C, D, E, F? So let us talk about tan of 420 degrees. So if you are looking at that, also rotate 420. As usual, we know this is 0, 90, 180, 270, 360. So you realize this is beyond 360. So continue moving. 360 plus 90, 450, plus 90, 450, plus 90, 540, plus 90, 630, 600 plus 90, I will have 720. So I need 450. So when I start from here, I move like this, I move like this, I come back here, I will have made 360. But 360, when I move up to here, it will be 450. So it means 420 is between 360 and 450. So it must be within this. So the whole of this angle is the angle which we are calling 420 degrees. So if the whole of this is 420, what is this remaining angle to the x-axis? So this, remember, we stopped at 360, that is 420 minus 360. So 420 minus 360, what will be the angle there? 420 minus 360, that angle should be 60 degrees. So the angle which is here, the extra angle here, the extra angle after 360 will be 60 degrees. So what does that imply? Tan 420 degrees is same as tan of 60 degrees. But what is the nature of sine? What is the nature of tan in this quadrant? The nature of tan in this quadrant is positive, so it will remain a positive angle. So tan 420 can be expressed in terms of acute angles, and that will be how we obtain it. So from there, please get for me this, your trial questions. I want to see who has got it right. One, express for me this one here, part A. What I want you to do is to express each of the following as trig ratios of acute angles. And what is our part A? Our part A, you will have 1 sine 620. Please put it in the comment section. I will go through and see whether what you are doing is right. So make sure you try this. So get for me this in terms of their corresponding acute angles. Yes, I want to check if you are getting it right. So that is how we express trig ratios of different magnitudes in terms of their corresponding acute angles. So that is how basically we do that. So basically the rule is you need to find the acute angle which is between the terminal side where you are stopping and the x-axis. And then you apply the correct sign according to the quadrant. So it means the quadrant is very important, and also the angle must be located with respect to the x-axis. Okay, so I want us now to come to what we call the trigonometrical equations. That is solving trig equations. So most equations in algebra have got a finite number of roots, but in many cases, trig equations have an unlimited number. So you can have an unlimited number of angles. For instance, when you are talking about the equation sine of theta is equal to 0, the numbers are very many. So we can briefly talk about that. Before we look at different equations, I want us to first of all look at this. There are some of the common things that we need to talk about, especially when you are talking about sine of theta, which is equal to 0, when you are talking about cos of theta, which is equal to 0. So let us first talk about this. If I have sine of theta is equal to 0, it means theta is same as sine inverse of 0, isn't it? But what is sine inverse of 0?
It is 0.
Is 0. Now, depending on what the range that you will be given, I want us to assume the range that we are having is negative 360 degrees, less or equal to theta, less or equal to 360 degrees. Whenever you get an angle like 0, 90 degrees, 180 degrees, those are angles that are already defined on the quadrants. For example, this is 0. This is where we have 0 degrees. This is where we have 90 degrees. This is where we have 180 degrees. This is where we have 360 degrees. Oh, 270 degrees. This is where we have 360 degrees. 450 degrees. 540 degrees. 630 degrees. 720 degrees. So whenever you get an angle which is like 0, now along this line here, where we have 0, 0 is along the x-axis. So any angle along the x-axis will give you sine as 0. In other words, when you have 0, sine of 0 will be 0. Sine of 180 degrees will be 0. Sine of 360 degrees will be 0. Sine of 720. So sine is 0 along this line, along the x-axis. So sine of an angle is 0 along the x-axis. So any angle you pick along the x-axis, sine will be 0. So it means sine is 0, sine of a theta is 0 along the x-axis. And for that case, it means the angles will be, we can either have 0 degrees, or we have 180 degrees, or we have 360 degrees, or we have 540 degrees, or we have 720 degrees. And if these ones are also positive, then remember you are taking this angle, which is 180 degrees. You come back here, you take this angle, which is 360. You go back, you take this angle. So whenever you are taking these angles, then what about their corresponding negative angles? If you start from here and also move like this, you get the first negative angle, and that angle will be negative 180 degrees. So it means as sine is 0 along this line, the angles you can take 0 and its negative angle. So it means 0, positive or minus 0 will still work, but since positive and minus of 0 remains the same, so we can maintain that as 0. But if you are having 180, it means also negative 180 can also be true, because sine of negative 180 will also give you a 0. So any angle along this line here, you need to always record that. Along this line, any angle that you pick will give you sine as what? Sine as 0. But when you talk about this line here, then sine will be defined. Either it will be positive 1 or negative 1.
1.
Now, along this line, let us first finish this. Along this line, we can have negative 180, but when you also continue moving and reach here, it becomes negative 360. So it means you can also have negative 360 degrees. When you continue moving, and this now becomes 540, it means also negative 540 degrees also qualifies. Also negative 720 degrees also qualifies. So any angle, whether positive or negative, so long as it is picked along the x-axis, sine will be equal to what? Sine will be equal to 0. Now, along this line here, which is the vertical line, along the vertical line, sine will be defined. Because along the vertical line, we can have 90 degrees here, we can have 450 degrees here,
50.
we can have 270 degrees here, we can have 630 degrees here. Along this line, sine is defined and it is positive 1 here and negative 1 here. These are standard numbers that you must always know, because when we look at the other angles, it will be easy to get the required angles. But because when you are talking about like sine inverse of 1, sine inverse of negative 1, cos inverse of 1, cos inverse of 0, you must be knowing some of these standard angles. And these ones are easy to define because 0, 90, 180, like that. You can easily define them. So I'm saying that along the positive y-axis or along the y-axis, sine is defined. Then along the positive one, sine is positive 1 here and negative 1 here. Meaning that sine of 90 degrees will give you 1. Sine of 450 degrees will also give you 1. But if this one is true, what about their negative angles? Remember that angles, we have two kinds of angles. Whenever you are measuring any given angle, it has got the corresponding positive angle and its corresponding negative angle. We shall be talking about that in details. Whenever you are measuring an angle, you must know that an angle has the corresponding positive and negative angles. So if I talk about 90 degrees, what is the corresponding negative angle of 90 degrees? Because to measure 90 degrees, I move from here up to this point. But what about if I take this direction? If I take this direction, this is 90 degrees, but this will be the corresponding negative angle. And what is that angle? When I move from here, I move up to this point, that angle will be negative 270 degrees. So what does this one imply? This implies that when I also take sine of negative 270 degrees, I also get 1. Is it okay?
Yes.
Because when I take sine of 90 degrees, I get 1. And 90 degrees, its corresponding negative angle is from here up to this point. So it means when I also take sine of negative 270 degrees, then I must also get what? Get 1. So it means whenever you mention an angle, you must also mention its negative angle. Now, this one here, we are saying sine here is negative. So sine is negative 1 when it is the angle is 270 or the angle is 630 degrees. But also when you define 270, you should also be able to define the corresponding negative angle, because the positive angle is from here up to here. Then the negative angle is from here up to this given point. So this angle here is 90 degrees, so which is negative 90 degrees. So it means sine is negative 1 at 270 degrees, at negative 90 degrees, at 630 degrees. Then also when you keep moving and come back here, that will be 450 degrees. So also negative of 450 degrees. So whenever you have like sine of a negative 450 degrees, then you should also be able to get negative 1. So we are going to talk in details about this. But these ones here, we need to be knowing some of these ones here, especially when you are looking at sine inverse of 0. Sine is 0 along this line, but it is defined along this line. Now, this is where sine is positive, and here where sine is negative 1. These are standard values, but we shall talk about them in general after looking at different questions. Then, what I also need to talk about is the one for cos. Please remember, when you are talking about sine, sine is sine inverse of 0. Along this line, sine is 0. Along this x-axis, sine is 0. Any angle along the x-axis. But sine is defined along the y-axis. Now, when we are talking about cos, for example, cos of theta equaling to 0. Where is cos 0? Cos is 0 along this line. So it is the vice versa. So when you have 90 degrees, you have 270 degrees, you have 450 degrees, you have 630 degrees. So whenever this one, any angle defined on the y-axis, cos will be equal to what? To 0. Meaning cos 90 degrees, cos 450 degrees, cos 270 degrees, cos of 630 degrees, all of these ones give you cos as cos of the angle as 0. But on this line here, cos is defined. Now that is the reverse of the sine. Along this line, sine is not defined, but along this line, sine is equal to 0. Along this line here, cos is defined. So when you pick an angle like 0, you pick an angle like 360 degrees, you pick an angle like 180 degrees. So all these ones, cos is defined here, and here cos is positive 1, and here cos is negative 1.
Negative 1.
Yes, so whenever you are getting like cos of 0, that is positive 1. Cos of 360, positive 1. Cos of 180, negative 1. And the same applies to their corresponding negative angles. So when you move from here up to here, you are taking negative 180. So meaning cos of 180 and cos of negative 180 will still give you negative 1. So that is for cos and sine. So whenever we are looking at cos of theta equaling to 0, then you should know that cos is 0 along this line. So you don't need to, first of all, look at it gives you hard time. So simply draw this. You know that cos is not defined along this line. So you take the angles. Any angle you pick along this axis here will give you cos as 0. So we shall look at this when we are looking at some of the questions. Now, I want us to start with this one here. It says solve the equation, and you are given sine of theta equaling to negative a half for values of theta from 0 degrees to 360 degrees inclusive. So let us talk about that. So we are given a sine of theta which is equal to negative a half. Now, whenever you are looking at something to do with a negative here, I would first of all wish that you consider the positive value. So consider sine of theta equaling to a half. When you do this, you are calling this one as the principal angle. In most cases, we call this one as the key angle. So don't simply take sine inverse of negative a half. So first consider when you are having a what? When you are having a positive. Now, when you consider it when you are having a positive, you will call that one as a principal angle, or what we call the key angle. The reason is this angle here is not part of the solution. So whenever you are looking at the solution, this angle, you don't take it to be part of your solution. Meaning the angle you are getting here, don't include it in your solution. Because your solution should include where sine is a what? Sine is a minus. So, but here you are considering sine as a positive. So why do we consider when sine is positive? The reason is we need to get an acute angle which will help us to get the required angles.
Angles?
Yes. Now, let us consider this. What is theta? Theta will be sine inverse of
a half.
A half. Okay, so what will be sine inverse of a half?
This 30.
It will be 30 degrees. Now, after getting 30 degrees, go back to your quadrants. Go back to the quadrants. So draw your quadrants here. Now, when you draw the quadrants, now you need where sine is a negative. Okay.
Negative.
Now, where do we have sine as a negative? In which quadrants do we have sine as negative?
The third quadrant and the fourth quadrant.
The third quadrant and the fourth quadrant. Now allocate that angle in those quadrants. When you allocate that angle in those quadrants there, so put this angle as 30 degrees. Put this angle as 30 degrees. Is that one okay?
Yes.
We are putting them in the quadrants where sine is a what? Where
Negative.
sine is a negative. So look at the quadrants, because the question wants you to solve sine of theta equaling to negative a half, but this is a minus, meaning that we need where sine is a minus. So we consider this one here as a positive to get this angle. And after getting this angle, it will help us to get the required angles. Now, locate where sine is a minus. Sine is a minus in the third quadrant and the fourth quadrant. Now, make sure you allocate those angles in those quadrants with respect to the x-axis. And after doing that, now start looking for the required angles. Now, the question wants us to get the values of theta from 0 degrees to 360 degrees. So it means we need only positive angles from 0 degrees to 360 degrees. So our theta requires us to get the angles from 0. Inclusive, this word is inclusive. It means 0 and 360 can also be included. So it means your angles for theta should be ranging here from 0 degrees less or equal to theta less or equal to 360 degrees. Meaning your angle can also be 0 or it can be 360 degrees. Now, let us get the required angles. When you are measuring angles, start from the x-axis. So move like this. Keep moving until you are able to meet the line in this quadrant. So this is the line. That is where you will stop. So what will be the values of theta here? So the values of theta will be, when I move from here up to this given point, what will this angle be?
It will be, let me see.
It will be 180 plus 30 degrees. And that will give us, it will be from here, we are moving from the positive x-axis. We start from here. We move from here up to when we meet this line where you have allocated that angle. So when we move like this, you move until you meet this line. That is where you will stop. And what will that angle be? It will be same as, because from here up to here is 180. Then we need up to here, so you add 30 degrees.
It will be 210.
It will be 210. So the value will be 210 degrees. And another value, still start from the positive x-axis. Start from the positive x-axis. Start from here. Again, keep moving until you meet another line in the quadrant that you are located. Is that one okay?
Yes.
So now measure that angle. What is that angle? When you move from here, you move up to this given point. So it will be 300. 330 degrees. So that will be the required answer. So these are the two answers that we shall have for the values of theta, because we need the values to be from 0 to 360 degrees. So these will be the required answers. So when you are including in your answers, don't include the what? Don't include the 30. The reason why we are not including the 30 is because we use the 30 as the key angle. This is the key angle. That is the angle to help you get the required angles. But now, if you had simply said sine inverse of negative a half, what do you think you would get? Sine inverse of negative a half. You would get an angle which is like negative 30 degrees, isn't it?
Yes.
So when you get such an angle, you might also come up with the required angles, but it will be hard for you to trace the required angles. So what we normally do is you use the positive value. When you use the positive value, get the key angle. After getting the key angle, use that angle to get the required angles. So first take it when it is positive, then get the required angles. So that will be a different case if the question had asked for the values where, for example, a sine of theta. If, for example, you were simply looking at sine of theta, is equal to a half. We can also talk about this. So when it is already positive, here, so you don't need to look at the key angle. So here you simply say theta is the sine inverse of a half. And your theta will be equal to 30 degrees, isn't it?
Yes.
Now, if you get that, now that one will not be a key angle because your sine of theta was the value we are considering here was a positive value. So now there you simply go to your quadrants again. From these quadrants, you need where sine is a what? A positive, because here they are saying sine theta is equal to a half, so sine is positive here. So look at the quadrants where sine is positive. So which quadrants do we have sine as positive?
The first quadrant and the second
The
quadrant.
first quadrant and the second quadrant. So put these lines. In the first quadrant, put another line in the second quadrant. Then have this angle, always from the x-axis, as 30 degrees. Have this angle as 30 degrees. Now from here, take the values of theta. Now we are looking at theta also similar range, 0 degrees, less or equal to theta, less or equal to 360 degrees. Now look at this. Take this angle, you start from this axis, move until you meet this angle, this line here. That will be your first angle. So the first angle will be 30 degrees. Next, you need to get another angle. If you need to get another angle, also start from here. Keep moving until you get that line that makes that angle. And that angle will also be from here. Measure from this point. Move up to here. So this up to this given point is 180 degrees. So if I need from here to here, I get 180, I subtract 30.
Give me us 150.
And that will be 150 degrees. So this becomes your answer. Now here 30 is included simply because it was not used as a key angle. But for this case, you don't need to include the 30 degrees. 30 degrees is to help you get the required angles. So that is our example 1, and I hope it is okay. Any challenge there in regards to our example number 1?
No.
Okay. So let us look at our next one. So the next one is solve the equation cos 2 theta is equal to that for the values of theta between negative 180 and 180 degrees. Let us talk about this. We are given cos of 2 theta, which is equal to positive. It is positive 0.6428. Now, when you reach here, since this is already positive, so there is no need of talking about key angle. So have 2 theta, which is equal to cos inverse of 0.6428. So get this value. Cos inverse of that.
Give us 50.
50? Okay, it will give us 50 degrees. Now, when you reach here, don't divide by 2. Okay?
Yeah. Yes.
So when you reach here, don't first divide by 2 to get what? 25. The reason is when you do that and allocate the 25 on the quadrants, that will be wrong. It will give you a wrong answer. So what we need to do, remember, we need for the values of theta in the range of negative 180 degrees, less theta, less 180 degrees. Now, when you reach here, you only divide after getting all the angles that are within the required range. So don't divide yet. Again, when you reach this given point, this value is 2 theta. But the given range is for what? Is for theta. Is that one okay?
Yes.
Now, what you do, you need to first of all get the new range. And the new range is for what? For 2 what? For 2 theta. Okay? The range that you are given here is for theta. But we also need to know where does 2 theta range from. Now, what we do is we need to create 2 theta, and we have theta. So what do? We can multiply through by what? Multiply here by 2, multiply here by 2, multiply this one by what? By 2.
2.
So when I multiply this by 2, it will give me negative 360 degrees, which is less than theta times 2, which will be 2 theta, which is less than 180 times 2, which is 360 degrees. So I'm saying whenever the range that you are given is theta, but here you are having like 2 theta, 3 theta, 2 theta minus 50 degrees, you must create that new range first. If you don't do that, then you might leave out some correct answers. So this was the given range, which was for theta here. The given range was for theta. But what we are having here is 2 theta. So if you have what you are having here is 2 theta, first get that range for 2 theta. So see how you can manipulate this and get that required range. So I have negative 180 less than theta less than 180. But I need 2 theta, so multiply through by 2. Now this is the new range. Now the reason why we are looking for this new range is we must get all the corresponding values of 2 theta when we have 50 degrees. That is why I said first don't divide, don't manipulate this until you get all the required values that correspond to 2 theta. Now, like what we did in our previous example, we shall allocate this on quadrants. Now, what you are allocating is a what? Is a 50 degrees. When you divide by 2 here, you will allocate 25, and that will be wrong. So, allocate 50 degrees on the quadrants. But we need where cos is what?
Positive.
Cos is positive. So, which quadrants do we have cos positive?
First quadrant and the first quadrant.
It is the first quadrant and the fourth
And the fourth.
quadrant. Now, in these quadrants, allocate there 50 degrees.
50.
Put here 50 degrees. Go on and put here 50 degrees. Is that one okay?
Yes.
You are not allocating that. As I said, if you divide here by 2, it means you will allocate here 25. And that will give you wrong answers. So before you do any manipulation here, whatever you get as cos inverse of something, sine inverse of that, that is what you allocate on the quadrants. Now, I have 50 degrees here, 50 degrees here. But my angles must range from negative 360 and 360 degrees. Now let us get those angles. So these angles correspond to 2 theta. So 2 theta is equal to, now the first angle you have 50 degrees. So how do we get that? Remember, you allocate the angles from this axis. Now start from here. Move up to there. This angle is it?
50.
This angle is 50
It is 50
degrees.
degrees.
Okay? Now, after getting this angle as 50 degrees, remember you are also interested in the negative what? The negative angles. Okay?
Negative angles.
So whenever you get
Yes.
whenever you get this angle, get its corresponding negative angle. How do we get that? By taking the clockwise direction.
Clockwise direction.
Yes. Now move like this. This one I took the anti-clockwise and I reached here. That is 50. So I take the clockwise direction. I move like this up to this point here where I meet this line. So this angle here is the corresponding angle of 50 degrees. So let us get that angle. From here, move like this up to here. So if you move up to this point, it means you will have made 360, isn't it? So I have
Yes.
this as 50 degrees. So the remaining angle is 360 minus 50, which is 310. But
Then
that angle should be what?
negative.
Should be negative. So this angle should be minus 310 degrees. So we have got a positive angle, which is 50. Its corresponding angle is also there. So each angle has got both corresponding positive and negative angles. Now let us go on. If this is what we obtain, this angle here, remember we also have the angle in this quadrant. So we also need to come there. So let us go to that quadrant as well. In this quadrant, still you will start from here, move until you meet that quadrant, that angle in that quadrant. Here. So when I move from here up to here, I get 50. That is the first angle. I move again from here. I come up to this given point. And what will that angle be?
Pardon?
I am moving from here. Remember, my first angle was in this first quadrant. In the first quadrant, and the next angle should be in the fourth
Quadrant.
So we began with the first quadrant by getting the positive angle, which was 50. So you moved from here up to here. That is the positive angle. But you also need the negative angle. That's why we moved like this to get the negative angle. Now, we are looking for another angle, which is in the first what?
Quadrant.
In the first quadrant. Remember, we are considering where cos is positive in the first quadrant and the first quadrant. Now, to get the angle in the first quadrant, still you start from 0, this axis here. You move following the anti-clockwise direction. You move up to this point. Now, where you meet this line is where you stop, and you take that angle. So the question is, what is that angle from here up to this given point?
310.
That angle will be
310
degrees. For it is positive because we are following this direction. Again, we need the negative angle for this. Can we also get that? For the negative angle, you are beginning from here, moving until you meet this line. We meet it here. That is where you will stop. So what will that angle be equal to? From here, you move up to here.
Negative 50.
That will be negative 50 degrees. Now from there, that is where you will stop. Remember, we haven't divided here.
Yes.
Now, these are all values which are corresponding to what?
Theta.
To 2 theta. But our interest is to get the value of theta. So the next step is to do division. Now what you do here is now divide both sides by 2. Divide through by 2. So divide 50 degrees by 2. What do you get?
25.
So the next one is to divide through by 2. So you are getting 50 degrees divided by 2. Negative 310 degrees divided by 2. 310 degrees divided by 2. Negative 50 degrees divided by 2. So you divide at the end. The division must be at the end. So therefore, the values of theta will be, so this will be 25 degrees, negative 310,
Negative 155.
negative 155. So this is 155.
155.
This is negative 255. So you can now rearrange them. So the values of theta in the range or in the interval of negative 180 to 180 will be in the interval between 180 degrees, negative 180 degrees, and 180 degrees will be. Now you list them. You can start with the smallest, negative 155 degrees, negative 25 degrees, 25 degrees, and 155 degrees. And these will be the values. And you can see that these values are in the range of negative 180 to 180 degrees. The values here. So if they are saying negative 180 to 180, make sure your values are strictly lying in that range. Now, from what we have done here, you can easily see if someone did get this new range, okay? And for you, you only considered this given range here. Then first of all, you would eliminate this angle. You would have eliminated this angle. So you would not be having this angle. So for you, you would concentrate between negative 180 and 180. So you would ignore the negative 310 and the positive 310. And which means that you would only be having two angles, that is 25 degrees and negative 25 degrees. So this is what is important. Whenever the angle here changes whether it is added like theta plus this, theta minus that, 2 theta, 3 theta, 2 over 3 theta, you must get the new what? You must get the new range. So whenever you get the new range, it will now help you to get all the angles in that given range. So you should always recall that. So don't simply rely on the given range of theta and yet your theta here is changing. And another thing, don't divide here immediately. Don't immediately divide this. So you have this one as 25, and for you use 25 here. When you use 25 here, then it means everything here will be wrong. So that is what you need to be recalling. So that is for this example number 2. Maybe in case you have any question there, then you can ask before we look at another example. So is this one very okay?
Yes.
Okay. So the next one is this. In case you need a break, you let me know.
Yes.
Can we go on?
Yes.
Okay. So in case there is something you maybe need to attend to urgently, you let me know. So you shouldn't remain here when there is something you need to attend to urgently. Now, let us try this other question here. It is saying that solve the equation 2 sine squared theta is equal to sine of theta for values of theta from 0 degrees to 360 degrees inclusive. Okay, so let us look at what we are given. We are basically given 2 sine squared of theta, which is equal to sine of theta. Now, when you look at this question, what someone can first of all do is to divide it through by sine of theta. But the moment you divide it through by sine of theta, you say divided by sine theta here, divide by sine theta here. That one becomes wrong. So that is what the first mistake majority usually do. So because they are saying this is sine squared and this is sine, so they want to divide it through. When you divide it through, that will become wrong because you'll be missing out some angles. So the first step here is not to divide it, to divide it through by sine of theta. Otherwise, some angles will be missed out. So what do we do first? So the first thing to do here, if you have such an equation, is to make sure you first take this one the other side. And again, what I need to caution is that when you have sine squared of theta, this can still be written as sine of theta, the whole of this squared. But sine squared of theta is not same as a sine of theta which is squared. These are two different things. Sine squared theta can be written as sine of theta, the whole of it squared, but sine squared theta cannot be written as sine of theta squared, meaning when you say sine of theta squared here, then this one will be completely wrong. Now, what do we do? So we shall bring this one the other side, and this will be 2 sine squared of theta minus sine of theta, which is equal to 0. So take this one, don't divide it through. Now, when you reach here, the next thing you can do is you can see sine is actually common. So as I said, this can be written as 2 sine of theta, the whole of this squared, minus sine of theta, which is equal to 0. Now, when you look at this, you realize that sine is common. So I can factorize out the sine. When I put out the sine, I will remain with, what do we remain with here? When you put sine out, what remains here when I put the sine, one sine out?
Another sine.
Here you remain with, I'm factorizing
Sine.
out.
the 2 sine.
I remain with 2 sine of theta minus
The sine theta also.
Minus sine theta also. Remember, the sine theta has been taken out. So if I put the sine theta out, it means here I remain with
1.
I remain with 1 because I've put 1 sine theta out. I've put this one out, so here I remain with 1 because this is same as 1 times sine theta. So this is equal to 0. Okay.
Yes.
Now from here, when you multiply this one back, you will get sine theta times 2 sine theta, which is 2 sine squared theta. Then minus sine theta times 1, it will be sine theta. Now, when you reach here, you can easily say that either a sine of theta is equal to 0 or 2 sine of theta minus 1 is equal to 0. Is that step okay?
Yes.
Now, from here, you are having sine theta equaling to this and 2 sine theta minus 1 equaling to that. So what we do here is now consider first sine theta equaling to 0. So what will be theta? Theta is sine inverse of 0. But what is sine inverse of 0?
0.
Sine inverse of 0 is 0. But do we have only 0? We need to have this one on our quadrants. Remember, we use quadrants to get other angles. And our angles, we need the angles from 0 to 360 degrees. So the angles we need should be between 0 degrees to 360 degrees. Otherwise, it's still 0 and 360 degrees are included, so that's why I'm using less or equal here. Now, 0 is here. But as we said, all angles on this axis will give you sine as what? Sine as 0. So along this axis, we have 0, we have 180 degrees, we also have 360 degrees.
60.
500.
We have 540.
Yeah, 540 degrees, then 720 degrees. Now, any angle that you pick here will give you sine as 0. That is what we said. So therefore, what will be the required values of theta then? So theta will be equal to, now look at the range. Our range should contain angles from 0 to 360. So what will be the values that correspond to theta?
I can say 180.
We can have begin with 0. We can have 0.
We have 0.
180.
80.
360. Do we have any other?
No.
No. These are the only angles that are satisfied by theta in this range. So these are the angles we shall consider. Now that is for the case where sine of theta is equal to 0. Sine of theta is equal to 0. But we also have this. So we must also consider this. So let us also consider 2 sine of theta minus 1 equaling to 0. Let us also talk about that. So can we have this one on the other side, such that this becomes 2 sine of theta, which is equal to 1. So from here, what you do, divide it through by 2, and sine of theta will be equal to a half. If sine of theta is equal to a half, what will be theta? Theta is sine inverse of a half. So what will be sine inverse of a half?
30 degrees.
Will be 30 degrees. So theta will be equal to 30 degrees. Now, after that, go to the quadrants. You need where sine is positive. Okay? So where do we have sine positive?
In the first quadrant.
We have in the first quadrant. So put those lines there. In the first quadrant and the second quadrant. But this cannot be done when we are looking at 0. That's why it is important to be knowing some of these standard angles, like where sine is 0. Sine is 0 is along this line. Any angle you pick here, sine is 0. So you need to be knowing this, because you cannot put like a 0 along this line like this, because that one cannot happen. So 0, 1, 8, these are standard angles. So the moment you know, like along this line, any angle I pick along this line, x-axis, sine is 0, then I simply look at the angles along this line. We have 0, 180, 500. So you take those angles either in the positive direction or the negative direction, depending on the range that will be given. Now, for this case, theta can be easily allocated there. So this is 30 degrees. This is also 30 degrees. Now, start measuring. We only need positive angles. That is from 0 to 360. So for that case, this is the range we are considering. So we need only positive angles. Now, for that case, let us look at the positive angles. So we shall start from here. We take the anti-clockwise direction. So that will give us the first value as the first value will be 30 degrees. Now again, start from here. Look for the another angle in the other quadrant. This is the angle. So we need from here up to here. So from here up to here, this is 180. So from here up to this given point, that is it.
150.
150. So this will be 150 degrees. So those are the only angles. So from that, then you must conclude. Therefore, the values of theta, remember this is one question. So you must have all the values of theta which are in the range of 0 degrees up to 360 degrees. Now combine all the angles. We had 0, 180, 360, 30, and 150. So combine all. So we shall start with 0, 30 degrees, 150 degrees, 180 degrees,
360.
360 was also there. Okay, yeah, 360 degrees. So those will be the required angles for that question there. Okay. So we have very few minutes to make it to 2 hours, and that is where we shall stop. So about 6 minutes for the 2 hours. Now, let us look at the next question. I hope this question is okay.
Yes, it's very okay.
Okay. So we have another question here, which might be our last question now. So it says, solve the equation tan theta is equal to 2 sine of theta for values of theta from 0 degrees to 360 degrees inclusive. Okay, so we are given tan of theta is equal to 2 sine of theta. Now, with this, you realize here you have tan, here you have sine. What we need to do first is to express tan in terms of sine and
Cos.
So what is tan in terms of sine and cos?
The sine
is sine
over cos
of theta divided by cos of
theta.
So this is equal to 2 sine of theta. Now when you reach here, you can cross multiply. So this will be sine of theta, which is equal to 2 sine of theta times cos of theta. Now when you reach here, again, don't divide through by what? Don't divide through by sine, because sine is common here, sine is there. So if you are very fast, you can say, hey, since sine is here, what I do, let me divide through by sine. The moment you do that, you are eliminating some angles. So don't do that. So what we can do is, we can bring this one the other side. So when you take this the other side, you will remain with sine of theta minus 2 sine theta cos
theta,
which is equal to
0.
What do we do next? You have sine theta minus 2 sine theta cos theta. Sine theta is common. Okay, so you can factorize out the sine theta. You remain with 1 here minus 2 cos of theta, which is equal to 0. Now from here still we can say that either sine of theta is equal to 0 or 1 minus 2 cos theta is equal to 0. Now consider each one of them at once. Consider each at a go. So consider sine of theta, which is equal to 0. Theta will be equal to sine inverse of 0, and theta will be equal to 0. But when you get 0, it does not mean that is the only angle. You need to again go back to your quadrants to get other angles. Remember, we need angles for which, let us go back to the range. The range is from 0 to 360 inclusive, meaning that 0 and 360 are included in that range, like the way we did for our previous case. So we are having our range. So they'll give the range that we are having is from 0 degrees less or equal to theta less or equal to 360 degrees. Now let us again allocate. So here theta is equal to 0 degrees, but as we said, if you have 0 degrees here, all angles on this line here will give you sine as 0. So you have 0, 180 degrees, 360 degrees, 540 degrees, 720 degrees, and many others, depending on the range you are having. But for our case, since this is our range, so the theta will be, take the ones which lie in the range.
This 0 degrees,
0,
180,
180, and
then 360.
Now, in case if they had said that you need values of theta from 0 degrees to 360 degrees, what would be your answer here?
If
they had said you give the values of theta from 0 degrees to 360 degrees, they don't put this word inclusive. What would be
then my angle the angle would be 180 degrees.
Yeah, the angle would only be 180 degrees. That is true. So it means the 0 and 360 will be eliminated from the answer. Okay. So let us also talk about this next one. That is 1 minus 2 cos theta is equal to 0. So,
excuse me, sir. I've tried for this one of 1 minus 2 cos theta.
Yes.
0, and I've got
you have got
I think the angles.
Yes.
The angles I've got 60
1
degrees.
minus 2 cos theta is equal to 0. So you are getting angles of theta as
60 degrees.
60 degrees.
And 300 degrees.
And 300 degrees. Okay, let us confirm that. So here it means you are getting your cos theta equaling to a half. So your theta is cos inverse of a half. Cos inverse of a half is it 60?
Yes.
Okay, so we need to locate that. Cos is positive in the first quadrant and the last quadrant. So that is 60 degrees. That is 60 degrees. So it means we shall take this angle, which is 60 degrees. That is right. We shall also take this angle, which is 300 degrees.
300 degrees.
So then after that, combine them, get all the angles. 0 degrees, 60 degrees, 180 degrees, 300 degrees, and 360 degrees. So that is the required answer. Now, on the same question, if they had said that you get the angles from negative 360 degrees less or equal to theta less or equal to 360 degrees, what would we do? Let us look at this. It means we are still using the same thing here. So you are using theta is equal to 0 degrees. So which other angles would we add there? So for the first case, you are having sine of theta equaling to 0, and your theta is equal to 0 degrees. That was our first case here. So what would be the required angles in that range there?
That range will start with negative 360.
So let us have this. So it means we would still have 0 here, 180 there, 360 there. Okay, let us first maintain those. Now, it means we would take 0. Then you would take the positive angle, 180. Whenever you take an angle, take its negative angle, okay? So what would be the negative angle?
It would be negative 180.
So the negative angle would be this, which is negative 180. Next, we also take from 0, we come up to 360. But you also need the negative angle, so you get 360 there. So what will be the negative angle? Is starting from here. So the negative angle is starting from here. You move like this, up to here again, which is
negative 360.
Negative 360. So that is what we would have. Then for this one here, for this one, our second case. So for our second case, we had allocated, the allocation will remain the same in this quadrant and in this quadrant, because you are looking at cos of theta equaling to a half. So the allocation is the same, but the angles will now, we shall have other angles there. We need to get the value of theta there. Value of theta here, we first take this.
Yes, to be 60.
Then whenever we take an angle, go on and take the negative angle. So we move again to get the negative angle of this. Yes. So we start from here using the clockwise direction until we reach here.
Yes.
So that would be
negative 300 degrees.
Negative 300 degrees. Okay, so this is for 60 degrees in this first quadrant. But we also need, in which quadrant? The fourth quadrant. So we also get the positive angle. Start from the positive x-axis, move until you meet that line there. So that would be 300 degrees. But again, you need its corresponding negative angle. As we said, we measure negative angle starting from here. So you move until you meet this line. And you are meeting it here. That is negative 60 degrees. So now for the angles in the range of negative 360 degrees, let's O equal to theta, let's O equal to 360 degrees, we would have the values of theta as now combine all of them. These and these. So we would have negative 360 degrees. Actually, okay, we have also only negative and positive. So we can have plus and minus here. Plus and minus 360 degrees, 180 degrees, plus and minus 180 degrees. There is a plus and a minus. We have 0 degrees. Which other? 60 and negative 60. So the angles cannot be repeated. You only write them once. So plus or minus 60 degrees. And which one else? 300. Positive and minus 300 degrees. So those will be the required angles for that given range. So that is how that one will be done. So depending on the limits that you are given, then you should be able to make sure that you exhaust all the angles in that range. So you will try for me this example here. Please put it down. Find the values of theta from 180 degrees to 360 degrees inclusive, which satisfy cos of theta is equal to negative a half. I hope you recall what we did when we are having a negative value here. You first consider it when it is a positive. Then get the key angle. That angle you are getting is the key angle. Then rotate where cos is negative. Then get those angles. Have you put that one down?
Yes.
So we'll also try this. Find the values of theta from 180 degrees to 360 degrees inclusive. which satisfy tan theta is equal to 1. That is done.
Yes.
Okay, then the next question. Okay, that one I need us to talk about it when we meet, especially when this angle changes.
Yes.
You will try for me this. Okay, you can simply take the screenshot. This is what we did first. You try and see if you are able to get this one here. Majorly part 2, question 2 there. So simply take the screenshot of that. Under question number 2, you have put this one down. You have put this one. This is cosec of theta is equal to that. And this, so you will try for me, these ones I've ticked. This one, I want us to discuss that one together, especially when the angle changes. But at the moment, you should be able to try for me those. For this one here, especially when angles change, I want us to discuss that one in our next lesson. So at the moment, try for me these ones here. For question number 2, these ones I've ticked. So leave out this part here. Leave out this part, we shall talk about it. And this part 3, we shall also discuss about it, especially when the angles change here. That is one of the most important parts that we need to discuss about how we get all the angles in that range.
Yes.
So that is where we shall stop for today.